Alright, so let's do a quick check to make sure we got what we've got 1.3 down so far. So in the 1.3 part 1 video, you should now have the ability to do all these different things. So let's see how we do. So A, the domain of F. Domain, we've got an arrow on this side, meaning it's going to keep going forever. We've got a closed dot on this side, meaning that it stops right here. This is where 6 would be. So that means our domain is going to be in interval notation. Negative infinity all the way up to 6. Remember, for domain, we think of that vertical line and we just pan it left to right. And where we hit graph, that's part of the domain. Okay? So from negative infinity because of the arrow, all the way to 6 for the x's, we hit graph. Alright, bracket on 6 because it was a closed dot, so it is included. Alright, now we switch and do the range. For range, we start at the bottom and we work our way up. Now, we don't hit the graph anywhere on the right until right there, but remember, there's an arrow over here to the left, and it's pointing downward. So it's going to keep going down forever and ever and ever. So the lowest y-coordinate is negative infinity. It keeps going down forever. So there is no lowest y. But there is a highest y-coordinate. If we start raising this horizontal bar up from the bottom towards the top, once we get past 1, we stop hitting the graph in any direction. So 1 is the highest y-coordinate. So we write 1, and 1 is included, so we use a bracket. Okay, the zeros. The zeros of a graph are the x-intercepts. This is another way to say x-intercept. So this is a 0, and this is a 0. So x equals negative 3 and x equals positive 3 are our zeros. F of 0. That's another way to say the y-intercept. But it's also a way to say what's the y-coordinate when the x-coordinate is 0. So you just go up or down from 0 until you hit the graph. And you see we hit the graph at 1. Alright, E. Intervals on which f is increasing. Increasing means it's going up from left to right. Okay, again, because of the arrow, we have to say it starts increasing at negative infinity. And it keeps increasing. It keeps going up and up and up until we get to right here. Negative 2. So at negative 2, it stops increasing. Okay, and it never goes back uphill again. It goes constant and then decreasing. So that's the only interval where we're increasing. F, intervals which we're decreasing. All right, we're increasing, we're constant, now we're decreasing. We're going downhill. So again, we're looking at the x-coordinates. Okay, so from 2 all the way to infinity, we're decreasing. And we don't include the endpoints. Okay, oops, sorry, we're not increasing to infinity. It's not an arrow on the right side. Okay, it stops. It's got a closed dot, so it's decreasing till 6. Okay, now even though that's a closed dot, we still do a parentheses because it's not decreasing at 6 because it stops. It's only decreasing on the left side of 6. It's not decreasing on the right side of 6. So 6 can't be included in the interval where it's decreasing. Okay, so just remember parentheses on both ends for increasing, decreasing, constant intervals. Alright, constant, it's constant between these two, so from negative 2 to positive 2. So, negative 2, positive 2, and again parentheses on each. Because we don't include the endpoints on those intervals. Alright, H. Intervals on, values of x for which the y-coordinate is positive. So, these were our two zeros, -3 and +3. And if you see in between those two, we have to go up to hit graph. So that means f of x is positive. It's the y coordinates for all these points in here that I'm putting dots on. The y coordinates for all those points are positive y coordinates. Down here, for instance, these values down here have negative y coordinates. So below the x-axis, f of x is negative, or f of x is less than 0. Above the x-axis, f of x is positive, or greater than 0. And we're being asked, where is it greater than 0? So between -3 and +3, we have to go up. So between -3 and +3, which is all of that constant interval plus these little pieces right here of the increasing and decreasing interval where we moved above 0 and then made our way back down to 0. Alright, values of x for which the y coordinate is -2. Okay, well here's the y coordinate of -2. So if I move over, I hit right here. If I move over, I hit right here. And the question is, what are the x values that are paired with those? Well, it's -5 and +5. Excuse me. J is f of 4 positive or negative. So find 4 on the x-axis. Remember, f of x is in the parentheses. So 4 is in the parentheses, so that means it's an x-coordinate. So find 4. There it is. That's the x value where x is 4. And it's asking, do you have to go up or down? If you have to go up, it's positive. If you have to go down, which we do, to hit the graph, then it's negative. Okay, is this function even, odd, or neither? Okay, this function has y-axis symmetry. If you look, it's a perfect mirror image. If I fold this over, I'm going to hit the graph on the right side. So this is a even function because of the y-axis symmetry. Alright, and then L. Is f of 2 a relative maximum? F of 2 right here. Is that a relative maximum? No. Now why? Because to be a relative maximum, we have to go from increasing to decreasing. And we went from constant to decreasing. Okay, so it's not a relative maximum. Alright, last thing from 1.3, very important for those of you going on to calculus, to get down the difference quotient. It is a huge fundamental topic in Calculus 1. The difference quotient is this formula where we really have to understand function notation to be able to know what we're doing here. Okay, so we're just simply subtracting difference and dividing quotient. But what are we subtracting and dividing? We're subtracting the expression f of x plus h, meaning plug in x plus h into the function, then subtract the original function itself, and then divide by h. So the first thing you're going to do is find f of x plus h. So take a second and plug x plus h into the function. So if I plug in x plus h into this function multiplies the input. Alright, the input is x. We multiply the input by 4. So if my input is x plus h, I multiply it by 4. And then, for the purposes of this difference quotient, you're going to simplify first. So I'm going to distribute, and I'm going to get 4x plus 4h. Okay, so f of x plus h is 4x plus 4h. So that means that I can replace f of x plus h with 4x plus 4h. Now, what do I do with that? I subtract f of x. So I'm going to subtract f of x. okay, which is minus 4x. And then I'm going to divide all of that, right, divide all of that by h. So if you look, what I've done here is f of x plus h is 4x plus h. So there's f of x plus h. There is minus f of x, 4x. And then I divided by h. Okay, so I'm just doing what the formula says to do. Now we just simplify. Now what you should see happen here, 4x minus 4x cancel, and we're just left with 4h over h. That should always happen. Your minus f of x should always cancel away with this f of x plus h expanded and simplified. So that should cancel. And then the other thing that should happen is your h in the denominator should at some point cancel. So we're just left with 4. Alright, now notice 4x is a line. Y equals mx plus b. Remember, that's a line. Oops. Line, not lime. And if you remember, m, the number in front of x, is the slope of the line. So the number in front of x here was 4, and we ended up with 4 as the difference quotient, which was the slope. So the question is, do you think that'll always happen? Do you think the difference quotient for a line will always be the slope? Well, here's another line. Let's see what happens. So first we need to find f of x plus h, which would be, it triples the input, so the input's x plus h, triples the input, then it adds 7. So distribute, we get 3x plus 3h plus 7. Okay, that is f of x plus h. So I'm going to plug that in right here. 3x plus 3h plus 7. I'm going to subtract the original function. I'm going to subtract the original f of x. So minus, this time because of that plus, I need parentheses. So 3x plus 7. And then I'm going to divide everything by h. Okay, so once again, this is f of x plus h. This is minus f of x. Right? F of x is 3x plus 7. So minus 3x plus 7. This is what we found when we expanded f of x plus h. Okay, so I'm just plugging into the formula. And again, the last thing is I divided by h. Okay, so now we just simplify. So 3x plus 3h, I'm just rewriting the original part, plus 7. Distributing the negative through, so minus 3x minus positive 7 is just minus 7 all over h. And if you see what happens here, I get a 3x and a minus 3x cancel. 7 and minus 7. So once again, minus f of x cancels away completely, and I'm left with just 3h over h, which is 3. So yes, the difference quotient of a line is the slope. Okay, the slope of this line was 3. The difference quotient was 3. Now, what if it's not a line? What if I have some other type of function? Well, it's still this. This is always the difference quotient. It's just you have to simplify and do the process. So there's again the formula for a difference quotient up here at the top of our screen. So the first thing you always do is find f of x plus h. Well, what does f do to the input? It squares the input. What's it going to do to this input? It's going to square this input. Now remember, x plus h squared is not x squared plus h squared. FOIL it out. X plus h times x plus h. X times x is x squared. Outside x times h is xh. Inside h times x is another xh. So I'm going to say that's 2xh. and then h times h is h squared. So we do get x squared and h squared, but we get this 2xh in the middle. Alright, now that is f of x plus h. So I'm going to replace this, x squared plus 2xh plus h squared minus f of x minus f of x, which is x squared, minus x squared all over h. Okay, x squared cancels with the minus x squared. We're left with 2xh plus h squared over h. Now, what I have to do here, what you have to know is we're not done yet. We have a common factor of h in the top. If I pull that out, I end up with 2x plus 1h. Instead of h squared, we're dividing by an h, so we get just 1h, or h to the first. And then that h in the bottom will cancel with that h we pulled out, and we're left with just 2x plus h. Alright, now that's the process every single time when you do these with a square. F of x equals 2x squared, so f of x plus h. What does the function do this time? It squares the input, then doubles it. So it's going to square the input, and then it's going to double it. Well, we know what happens when it squares the input. That's what happened right here. We get this. So 2 times x squared plus 2xh plus h squared. X squared plus 2xh plus h squared. And then we double it. We distribute that 2 through. We get 2x squared plus 2xh plus, plus 4xh. Sorry, I missed my distributing that 2 through right there. 4xh plus 2h squared. So that is f of x plus h. That's what I'll replace right here. So 2x squared plus 4xh plus 2h squared minus, alright, from the subtraction, f of x is 2x squared all over h. Alright, once again, f of x cancels away. I'm left with 4xh plus 2h squared. I'm going to go ahead and pull that h out like we did last time as I rewrite it. So h comes out, I'm left with a 4x here, and I'm left with just a 2h here because of the square. We're pulling out an h, so we're just left with plus 2h. Then we divide by h, so that's going to cancel once again. And we're left with 4x plus 2h. Now, you may be noticing the little pattern going on here. 2x squared, when it's a 1x squared, we end up with 2x plus h, or 1h. 2x squared, we end up with 4x plus 2h. If it were 8x squared, the difference quotient would be 16x plus 8h. It's always, if it's ax squared, for instance, a meaning anything, the difference quotient is always going to be 2a, whatever double this number is, times x, plus a times h. That'll always be the difference quotient, or something times x squared. Alright, now, the toughest one you'll see here. Now, if you get to, when you get to calculus, like I said, you need this for calculus. You'll see much tougher than these. But for right now, just to get the hang of it, this might be the toughest type that you'll see. You got an x squared and an x term. But the process is always the same. First, find f of x plus h and simplify. So this thing takes x and it squares it. Takes the input and squares it, and then multiplies by negative 3. So x plus h, we're going to square that and then multiply by negative 3. But we're also going to take that input and double it. and add that to negative 3 times the input squared. And then finally we're going to subtract 1. Okay, so again, you think of it as we're just replacing x with x plus h. Now, we know what this is. We did it last time. Again, it's not x squared plus h squared. It's x squared plus 2xh plus h squared. Don't forget that middle term. Okay, here just distribute. We get a 2x plus 2h. And then a minus 1. Okay, distribute that negative 3 through. We get negative 3x squared. Negative 3 times 2 is minus 6xh. Negative 3 times h squared is negative 3h squared. Alright, and then just the 2x, the 2, that should be an h. 2h minus 1. Okay, now, all of it is simply just f of x plus h. So all we've done so far is just found what we're going to replace this with. So I'm going to replace f of x plus h with minus 3x squared. Alright, I've replaced f of x plus h with all of that. Minus 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 1. Okay? Now, minus f of x. Once again, f of x has subtraction and addition in it, so I'm going to need parentheses. So the original f of x was 3x squared plus 2x minus 1. And then all of that is over h. Okay, so just like before, there's minus f of x minus this was f of x. And I'm just plugging in what we did before. And then there's the h on the bottom. So I'm just plugging into the formula what I need to plug into the formula. Okay, now let's simplify. So minus 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 1. Now distribute. Minus 3x squared is plus 3x squared. Minus positive 2x is minus 2x. Minus 1 is plus 1. All over h. And like always happens, these things cancel. Minus 2x plus 2x plus 1 minus 1. And the only things left are minus 6xh minus 3h squared plus 2h. And then if we do like we do in every one of these problems that have an x squared at the beginning, pull out that common h, we have a minus 6x, a minus 3h, and a plus 2. All over h, and then the h is canceled. We have the minus 6x minus 3h plus 2 as our difference quotient. Okay, now think about what we've been saying with this one. I'm going to go erase this real quick. When I look at this, I see a parabola, the ax squared, and then I see a line. I look at it in two pieces. So if you apply what we just learned here, ax squared, the difference quotient, is double whatever that a is, and multiply by x. So this is a, so double that, and multiply by x, so that would be negative 6x. And then add a, whatever the number in front of x squared is, times h. So the number in front of x squared is negative 3 times h, so minus 3h. Alright, there's the difference quotient for the 3x squared part. And then the difference quotient for this is a line, So the difference quotient for the line is just the slope of the line, which is 2. And what we end up with is an easy way to get the difference quotient even for these tough ones. If we just split it up into the ax squared look and then the mx plus b look, the line. So that's the difference quotient for 2x minus 1. And if you look, that's exactly what we have over here. Okay, so you can split it up that way if it makes your life easier, which it will. Alright, so there's your 1.3 notes. Let me know if you have any questions.